If I were to ask a seemingly naive question, how a typical vocational training is imparted in India, the obvious answer would be somewhat like this. There is a classroom with a lab, a qualified instructor, a manual for the instructor, and a workbook for students, an overhead projector, a laptop containing some videos, and how and what to do type instructional material. More specifically, let's take an example of an apparel manufacturing training center. It will have job cards, tailor's chalk, single needle lock stitch machine, measuring tape, manuals, smart board, instructors, and so on. Or take another example of a welding center, welding training center. It will have TIG welding accessories, arc welding machines, wire welding accessories, shielding gas accessories, manuals, instructors, and so on. The latest advancements in the field of vocational training is making all the above completely redundant. Deployment of augmented reality for self learning is making physical facilities, instructors, equipments completely obsolete, and training anywhere and everywhere is becoming a reality which has tremendous cost saving implications apart from bringing about a disruptive change. Let me elaborate what are those changes using uh, augmented reality in this podcast. Couple of weeks back, a report by ILO and Institute for Human Development has highlighted the issue of high unemployment amongst India's educated youth, pointing out that in 2022, the share of unemployed youths in the total unemployed population was 83%, 82.9% to be precise. One of the reasons for unemployment among youth is the significant disconnect between the school education and the opportunities, skills, and exposure necessary to achieve full potential to earn livelihood. As we move deeper into the era of Industry 4.0, characterized by automation, digitization, and interconnectedness, the landscape of industries worldwide is undergoing um, rapid transformation. This shift brings about a pressing need for technical and vocational education and training institutions to adopt and evolve in order to equip individuals, the learners, with the skills necessary to thrive in this new industrial paradigm. With industries increasingly relying on advanced technologies such as artificial intelligence, robotics, and the Internet of Things, there is growing demand for workers proficient in these areas. Thus, TVET programs must be agile and forward thinking, integrating emerging technologies in their curricula, thereby fostering a culture of lifelong learning and adaptability among students and workers alike. Augmented reality, AR in a short form, presents, in my view, a promising avenue for upskilling individuals within the context of Industry 4.0, particularly in addressing youth unemployment in India. By leveraging the augmented reality technology, TVET institutions can offer immersive and interactive learning experiences that simulate real world scenarios encountered in industrial settings. Augmented reality is a technology that combines two-dimensional and or three-dimensional virtual objects into a real environment and then projects these virtual objects in reality in real time. Through this AR technology, users can see virtual objects added to the real world with contextual information. In education, Augmented reality has been widely used in China to complement the standard curriculum. Text graphics, videos, and audios can be superimposed into the students' real time environment. Through augmented reality enhanced training modules, learners can gain hands on experience with cutting edge technologies, develop problem solving skills, and familiarize themselves with industry specific processes and equipment. Moreover, augmented reality, in my view, can bridge the gap between theoretical knowledge and practical application, enabling learners to acquire valuable skills in a dynamic and engaging manner. The research that was carried out in China in this context proved that students detest too much of theoretical inputs, and that's one major reason for them to get away from vocational training. In the context of India's youth unemployment challenges, augmented reality powered upskilling initiatives hold the potential to empower learners with the specialized skills demanded by the industry 4.0, thereby enhancing their employability and contributing to the nation's economic growth and competitiveness. Now, let me answer this question: what impact TVET will have by the use of augmented reality? Let me very briefly elaborate on this. By using augmented reality, learners can have a real world experience and insights into the products they design and interact with. In addition, the assembly of the final product is carried out 10% faster. Use of augmented reality will enhance the attractiveness of learning through, through and through. The use of AR to improve communication and collaboration skills between students and game based student assessment and evaluations in various teaching areas will allow for a stress free testing environment. Augmented reality based flipped learning is not only beneficial for learners in terms of improving their project performance, but also increases learners' motivation, critical thinking tendencies, and the self efficacy of the group as a whole. The integration of AR technology in training and further development will lead to significant cost reduction, as you may not require a lab, a trainer, digital content, nothing of that sort. It can be anywhere, everywhere, by everybody. All you need is a smartphone. Augmented reality experiment in higher education for complex system appropriation in mechanical design assistance in follow procedures like handling operations in practice sessions or assembly disassembly operations will become more efficient from transfer of learning point of view. Here, augmented reality is used as an educational support tool and introduces students to technology relevant to the industry. Almost all trades that are taught to students could greatly benefit using augmented reality. The application of AR will allow the utilization of different platforms to suit easier implementation in any industrial environment at a low resource cost. This is extremely relevant in the Indian context, where cost has been often cited as a major cause for students not getting enrolled in the training programs. Thus, breaking the boundary between the device utilization of similar platforms, the learner's proposed collaborative design combines most of the existing devices in a more realistic collaborative experience, if you will. AR effectively and seamlessly assimilates disruptive technology. Theme based projects that use augmented reality can facilitate students to think outside the curriculum, and industrial projects help them to adjust to industry expectation. The application of augmented reality technology in learning materials helps the learning processes and increases the impressive and fun factor, which is so very important in the learning process and makes the learning process more interesting. The application of AR in learning materials provides more information about the object being studied, information about the shape, its texture, and provides more visualization of the object. Designing and evaluating a highly interactive augmented reality system helps learner in reduce their cognitive load and obtain a high level of technological acceptance. It will help gain useful insights into collaborative learning, as I mentioned earlier, and serves as a good starting point for future projects. Engineering simulations with AR can facilitate versatile and sustainable educational tools for use in active learning environment. To conclude the discussion, the ultimate goal of vocational education training and the on the job training is to enable organizational members to achieve workplace goals, improve learners' knowledge, skills, attitudes, and enhance individual capabilities. Traditional training methods have proven helpful throughout the years. However, these methods, I'm afraid, may not be suitable for future trends in vocational education training or on the job training. In some ways, traditional training still suffers major limitations in helping learners acquire knowledge and skills, such as costly processes and considerable resources and time. Compared with conventional training, augmented reality based training can enable more professional immersion by seamlessly integrating real and virtual scenes. Thank you.